Uh, Hi everyone. Myself Omkar Saswat, and I'm doing PhD under the supervision of Dr. Priyanka Heda Maheswari, and I'm presenting my poster on the topic of the evaluation of biodegradable calcium engineered film for the packaging application. Here I'm working on biodegradable material like engineered film. I have prepared them on the by followed these experiments. Like I have taken alginate powder and make an aqueous solution of them. And after the cross linking, I have made alginate films. And these are the um, properties of these films, like with the ID T1, T2, T3, T4. Whereas T1 is the 15 minutes cross linking time at a constant calcium chloride concentration that was 3% and sodium alginate concentration that was 5%. And T2 is the 30-minute cross-linking time. T4 is 45 minute. T sorry, T3 is 45 minute and T4 is 60 minute. So uh, these are the properties in table one, in which we get that the average thickness is approx 0.032 mm, and the thickness variation is maximum is goes on 11.04, which is allowed as per IS 2508. I have followed these IS for the work and characterizations, and the density variation also had given there. The moisture percentage is maximum is 6.0, which is very less, and biodegradable. Now I'm going to result and discussion. Once I have study about tensile strength and elongation percent, I get that the maximum tensile strength is approx 17.5 for the T2 sample, and maximum elongation percentage is approx 78%, which is also for the T2 sample. And next one is the water uptake and swelling ratio. In water uptake, when we increase the concentration of sorry, when we going to increase the cross-linking time from T1 to T4, the water uptake percentage going to decrease with increasing the cross-linking time. And therefore, also same pattern has been followed as for the swelling ratio. Means that when we give the time for cross-linking, then maximum number of calcium which is present on the surface going to cross-linked from the sodium alginate, then film going to be cross-linked and behave like as a hydrophobic nature. And the third one is the solubilized matter in water. Means that when we dip our film in water for some times, like till 60 minutes, and after stirring we characterize them, then we get that some amount, a few amount of the calcium chloride or a calcium are dissolved in DI water, then we get that some excess amount of calcium chloride are presented on the surface of the film, and solubilized matter in water also decreases with increasing cross-linking time from T1 to T4. And the last one is the study of thermal degradation. In the thermal degradation, we get that when we this study has been carried out in the presence of sunlight at the temperature 20 for 24 hours at temperature 40 degrees centigrade plus minus 2. So in this study, when we increase the cross-linking time from T1 to T4, the thermal degradation time getting decreased at constant temperature and time. So after the T1 to T4, the thermal degradation also decreases with increasing cross-linking time. And last one is the biological degradation in different medium. We have tested the degradation time of the films in three mediums: soil, compost, and mixture of soil and compost. The mixture of soil and compost are the 50-50, means that 50% soil and 50% compost. And these characterization have been carried out in 80 to 90% moisture percentage in uh, medium like soil compost and soil and mixture of soil and compost. In this, when we increase the cross-linking time from T1 to T4, especially if we going to compare in compost, then we get that the T1 sample shows the best result in compost and other also. But for that, the tensile strength was not good. But for the T2 sample, the degradation time is 302 hours in soil and 184 hour in compost. So we get the we can say that the T2 sample shows the best result as compared to T1 or T3 or T4. So the conclusion of my study is different characterizations shows that lower concentration of calcium chloride, which is the 3%, with 30-minute throttling optimized time is shows the best property. For the T1 shows the best result in biodegradability, I have told previously. Due to the less water uptake, high mechanical strength and better biological degradation time, calcium alginate can be used as a packaging material. So I have been, I want to acknowledge Director of NPL to presenting my work, who is allowed to presenting my work, and my supervisor, CSIR, for funding my research work, and SS Sarda, the mechanical testing, and Shravan Kumar for the solubilized matter in water study. Thank you.